Tiga. Assalamualaikum and good afternoon. We are from Group 5. Today we are going to present inventory model. First of all, thank you for Professor Madya, IRTS, Dr. Faizal bin Abdul Aziz for giving us chance to present our project today. So I will introduce my name. My name is Muhammad Kushairi bin Syari. My matrix number is 194525.
My name is Razan, matric number 193247.
My name is Rafi Azim bin Johan. My matric number is 193767.
And the last one, my name is Muhammad Rizman bin Fazli. My matric number is 192026.
I will start with the introduction of an inventory model first. Next slide. So what is inventory model? It is a mathematical model that determines the optimal level of inventories in production process. The production process include managing frequency of ordering, deciding on how much quantity of goods or raw material need to be stored, the tracking flow of the product, and the supply of raw material and goods. It is important to provide uninterrupted services to customers without any delay in delivery. The purpose of this inventory theory is to determine the rules that management can use to minimize the cost associated with the maintaining inventory and also meeting the customer demand. Inventory model is a suitable mathematical model to know when we should order or be placed for a product and the exact amount of the order. Next slide. So there are several costs that involved in this mathematical. So the first one is ordering and setup costs. This is the cost that not depend on the size of the production, but it's related with ordering or producing the product internally. For example, the cost of paperwork and billing related with order. If it is ordered from an external sources, the labor cost for setting up and shutting down a machine for operation will be included. The second one is the unit purchasing cost. This cost includes variable labor costs, overhead costs, raw material costs associated with purchasing or producing single unit. And the third one is holding or carrying cost. This is the cost of carrying one unit of inventory at a period of time. The holding costs usually are storage costs, insurance costs, and also inventory taxes. So I will pass up to another presenter for the next slide.
All right, so I'll be presenting about the economic order quantity. So the introduction of it is economic order quantity, or EOQ, is a measurement tool used to determine frequency and volume of orders in operations, logistics, and supply management. So EOQ only looks at the inventory side of a business, right? So the measurement tool is useful to satisfy certain levels of demand and minimizing cost of orders. These costs consist of holding costs, shortage costs, and order costs. Next slide. A little more about EOQ. It is important for companies to help minimize cost of ordering and holding inventory because the cost of inventory may increase as a result of increase in size of inventory. So businesses that hold inventory a lot, such as airports or warehouses, will definitely need EOQ to manage their inventory costs. Another important use of EOQ is the use of cash flow tool. By utilizing EOQ formula, the company is able to control the amount of cash used by the company's inventory. So this is beneficial for companies, again, that rely on inventory such as manufacturers. Now, EOQ will then save the company money spent on inventory and will be able to use the money to invest in other aspects of the business. Now, next. Now, looking at the formulas and calculation, the formula for EOQ would be Q equals square root 2DS over H. Q is the EOQ units. It can be the amount of inventory or the number of units held in the inventory. D is the demand in units, usually in annual base. S is the order cost, H is the holding cost, C is unit cost, and I is the carrying cost. Carrying cost is the interest rate. Now looking at the example. So I have two examples. The first example, a retail clothing shop carries a line of men's jeans and the shop sells 1,000 pairs of jeans each year. It costs the company RM5 per year to hold a pair of jeans in the inventory, and the fixed cost to place an order is RM2. So this is a very straightforward example. So to solve, we apply the EOQ formula, which is Q equals square root 2ds. 2 is the constant. D would be the holding cost, which is 1,000 pairs of jeans. S would be the cost, the fixed cost, which is RM2. And H is the holding cost, which is RM5 per year. So we get 28.3 pairs of jeans. So we round it off, it'll be either 28 to 29 pairs of jeans. Right, so now looking at the second example, for the example would be a company faces an annual demand of 2,000 units, not specified what kind of unit, but it costs the company 1,000 ringgit for every order placed and RM 250 per unit of the product. So it faces a carrying cost of 10% of a unit cost. So the question is asking what is the economic order quantity, or EOQ. So as you can see here, 10% of the unit cost would be the interest. So this calculation would be taking into account that. Now, looking at the table, we have D, Q, S, C, H, and I. D would be the holding cost, which is holding units, which is 2,000 inside the inventory. S would be the ordering cost. C is 250, H is 250, and the interest is 10%. So again, we use back the equation, square root 2ds over H. And over here, H and I, the 10% interest rate is actually H. So H is just the quantifiable amount of the percentage of the interest rate. So 10% of C, which is 250 ringgit, which is 25 ringgit. So that's why H is 25 ringgit. So after solving the equation, we get 400 volumes per order. So the conclusion of this example is that the ideal order size to minimize cost and meet customer demand is 400 volume per order. All right, that's it from me. Thank you.
Okay, I will continue with the economic production quantity. The difference between economic production quantity with compared to economic order quantity is that there are the inclusion of the production rate. Next slide. Okay, what is economic production quantity? It is amount of a product that should be created in a single batch in order to minimize the overall cost, which include machine setup and inventory holding costs. It is also used to calculate the appropriate order quantity to place with a supplier in order to minimize inventory expenses while maintaining a balance between inventory holding and average fixed order costs. Economic production quantity is also adequate to ensure uninterrupted work. Okay, next slide. There are several differences between the EPQ with the EOQ. The formula is Q equal to square root 2 constant times the D times K divided by H in the bracket 1 minus D over P. Whereas Q is the optimal production quantity, D is the annual quantity demand, P is the production rate, K is the cost of production run fixed cost, and H is the holding cost of the variable cost. The Q stands for optimal production quantity, yes. Okay, next slide. There are several limitations of EPQ model unrealistic assumptions. The first one is models imply that the products or parts holding cost, ordering cost, demand, price, and quality are consistent throughout the course of the year. In the actual world, this is impossible. Second one is constant demand, like the price of a commodity, is improbable. They vary considerably in the actual world. Holding and ordering costs may vary due to change in rentals, salaries of personnel, and other overhead expenses. Consumer income, taste and preferences, input and raw materials, pricing, seasonal change in demand, and so on are all critical elements that impact both demand and pricing. Next slide, we continue with the example. Example 1, a computer technology company sells 0.3 million computers per year at a constant rate. The company owns a factory and produces all the computers they sell. The production setup its cost is 6,600 per production run. The producing cost is 500 per computer. The holding cost is 30 per computer and per year. The production rate is 0.5 million. So the question is, what is the EPQ of this company? The variable that had been listed up is the D is 0.3 million computers per year. The K is 6,600 per production run. The P is 500 per computer. The holding cost is 30 and the production rate is 0.5 million. Next slide. Okay, so the formula is EPQ equal to, or we call it X star, square root 2 KD over H bracket 1 minus D over P. So 2 is the constant, K we put inside all of the variables that has been listed out. The answer is 18,195.9. So the cycle time is equal to EPQ divided by the production. D is the computer per year, and we got it about 22.1 per day. So the number of production run is D divided by the EPQ is equal to 16.5 productions per year. The annual setup cost is equal to annual holding cost. So we put inside all the information and we got 108,995.4 dollar per year. The next example will be explained by Kushairi.
Thank you, Rizwan. I will proceed with the second example. So the second example question is a toy manufacturer use 48,000 rubber wheels per year for its popular dump truck series. The firm make its own wheels, which can be produced at a rate of 800 per day. The toy truck are assembled uniformly over the entire year. Carrying cost is $1 per wheel a year. Setup cost for a production run of wheels is $45. The firm operates 240 days per year and determine the optimal run size. So from the question, the variable D, which is the annual quantity, is 48,000 of rubber wheels. P, which is the production rate, is 800 per day. H is the holding cost, is only $1, and the setup cost is $45. Next slide. So we can use this formula, which is square root of 2ds over H time with square root of P minus P minus U over P minus U. So we already know the variable of D, S, H, but we need to find the value of U. So what is U? U is actually the D, which is the annual quantity over number of working days. And we already know the working days is 240 days. So 48,000 unit per year divided by 240. And we get U with the value of 200 units per day. And then we insert the value into the EPQ on the right hand side, which is 2ds over H. 2 is the constant, and we time it with the 48,000, and we time it with $45, which is the setup cost, over 1, which is the holding cost. And then we times with 800, square root of 800 over 800 minus 200. And then we get the answer is 22,078.5 and times with 1.155. And after we multiply it, the answer is 2,400 units, which is the optimum run size of this firm. So I think I will proceed with Rafiq Azim for the next slide.
Okay, thank you, Kushairi. Okay, so next is a quantity discount model. So a quantity discount model is basically a price reduction granted by vendor for large quantity orders. It's a compensation for those that purchase in large quantities, meaning that if you purchase more and you'll get a discount for that amount of large quantity that you purchase. All right, so basically there's two types of discounts, all unit discount and incremental discount. So all units discount is that the customer is offered discount on all the items purchased. Doesn't matter the quantity of the items. And incremental discount is offered to customers on every extra item beyond a certain quantity. The more you buy, uh, there'll be better discounts. So the goal of this discount quantity model is that it's to select the order quantity that will minimize total cost, where total cost is the sum of carrying cost, ordering cost, and purchase cost. All right, so in order to calculate a discount quantity model, it doesn't matter what you use to aid in the calculation. So, but basically the variables are carrying cost per unit, ordering cost per order, annual demand, unit price, and order quantity. All right, so we'll go to the example for this model. So a retail store dealing in computer hardware imports an enterprise model solid state drive at a fixed price of $1,000 per unit from the sole distributor of the SSD. On January 1st, 2014, the store received an offer of 15% discount on orders of 300 or more units. So it means that if you purchase more than 300 units, you'll get a 15% discount. Provided further that the estimated sales for the year are 600 units, the cost incurred per order is $1,000, and the average holding cost per unit per annum is estimated to be $120 per unit. The full price is likely to remain $1,000 during the year, should the store proceed with the quantity discount. Alright, so this is the solution. First, we have to calculate according to EOQ, where we use the formula 2 times the demand times order cost divided by the holding cost per unit. So, and we put all the variables into the formula and we'll get 100 units. So the EOQ for this problem is 100 units, and the discounted order quantity, if you remember, more than 300, you'll get a 15% discount. So it's 300 units. So annual orders under EOQ equals to demand divided by EOQ, which 600 divided by 100, which we will get 6 orders, while annual orders under DOQ equals to demand divided by DOQ, 600 divided 300 equals to 2 orders. So average inventory under EOQ is 50 units, and average inventory under DOQ is 150 units. Alright, so this saving from reduction in price. To calculate this, you get to demand times full price times the discount rate. So we get 600 times 1,000 and times 15%, which equals to 90,000. And saving from reduction in orders, we calculate by multiplying orders reduced and order cost, which is 6 minus 2 times 1,000 equals to 4,000. And then in the increase in holding cost, it equals to increase in average inventory times holding cost per unit annum equals to 150 minus 50 times 120. So the total is 12,000. And lastly, the net effect on income after we calculated them all, the formula is price plus orders minus cost. So it's 90,000 plus 4,000 minus 12,000, which equals to 82,000. So since the net effect on income is positive, the store should proceed with the quantity discount. All right, so that's all from me.
Thank you, Rafi Azim. I will proceed with the conclusion. So to be concluded, the perfect production in manufacturing system can lead to damaged product. Process reliability must be improved in order to maintain the product quality and also to eliminate the defective items. Increased reliability, on the other hand, leads to an increase in operating costs and as a result, a decrease in profit. In order to maximize profit, the highest level of reliability must be maintained. This can be achieved through three models that we had just explained just now to ensure having a minimized management cost associated with maintaining inventory and also meeting a customer demand. So I think that's all from us. Thank you.